Hey, it's Johnny Chappell. We're on Tower Street inside the Beltline in Raleigh, where we have the collection of very modernist but also net zero, passively designed homes that are truly unlike anything you're going to see on the market in Raleigh, and are just really, really, really special homes that look like they perform under the hood just as well as they look from the exterior. Will Alphen is the lead designer. He's the general contractor. He's the developer. He lives in one of these houses. So who better to talk about Tower with other than Will? So Will, give us a little bit, first of all, your background and kind of how this vision came to life.
Yeah, born and raised here in Raleigh. Ended up going to NCSU, College of Design for Architecture, and started a business over 20 years ago here doing design and construction, mostly for clients, so people hire us, they tell us what they need, we design it, we build it. And from the very get-go, my college education, I learned about climate change and sustainability, and that's always been a key focus of our work. So I got to a point in my career where it's like, well, wouldn't it be cool to do a project that really puts forth the sort of highest and best values that we have, and also what we've learned about design and construction techniques through our 20-some years of experience, to like put what's the very best thing that we could put out there on the market, to see if there's anyone else out there that would be would agree with that and be interested in living that way. And so that's what we've done.
To a lot of folks, all the components that go into a home like this to make it truly green built or passive or net zero, it can be intimidating thinking about all the different components that might make up that envelope, make up that property. Give us, from a high level, some of the must-haves to make a home perform the way that these do.
Well, it's you start with an energy efficient envelope, right? So it's really these are built in sort of the passive house tradition, which is the highest energy efficiency standard in the world. While we're not going for certification, we're using that as our guidebook. Okay. And so the tenets of that are a super insulated, energy efficient envelope. It's really just a measurement of how much energy you're using. Mm-hmm. So you start with a super energy efficient envelope. What that means is it starts with super insulation. So we've built our walls here. The inside of our walls are 9.25 inches thick. A typical home in Raleigh has 3.5-inch thick walls, maybe 5.25-inch thick walls if they're using 2x6s, which is sort of a modern update to the code. We're going 9.5 inches. So that gives us the space to do a deeper insulation. We've also framed these homes in a way that no one else is doing in Raleigh, and that we've balloon framed them, which is actually a very old-fashioned way of framing, where the walls go from the foundation all the way up to the roof, and then our floor lives in between. And what that does is that allows our insulation to be continuous.
Okay.
So we really focused on a lot of details, construction-wise, to have that insulation layer be completely uninterrupted. Your typical home is taking that 3.5 inches of insulation, and they're throwing wires in it. They're throwing big 2-inch pipes in it. Yeah. They're throwing a bunch of stud packs in it. They're just throwing anything they want in there. And then, so the insulation is the first thing that gets compromised. So we are minimizing the framing that's inside the wall, creating continuous insulation. And one of the ways we do that is then we fur out inside another 1.5 inches, what we call a service cavity. That's where all our wires run. That's where all our plumbing pipes run. So we have very few penetrations through the exterior wall, and we have very few pipes and systems inside the wall.
And so it starts there with kind of the envelope, as you said, and this continuous insulation that's not interrupted by wires and plumbing and all the things that we normally see in houses. How much of getting to that passive standard is in just the envelope itself?
Well, it's critical. So the insulation makes up a huge piece of that. And then our doors and windows are the other sort of main component, right, of our envelope. And so we're using a super high efficient door window product from Germany. So while we've built a lot of this locally, and it is a very local product, there are a few components of the buildings that are most of them from Germany. because they do have a focus on energy efficiency and high performance and high quality. So our windows are an example of that. Our windows are so efficient as an envelope system that you could take that typical 2x4 wall on a typical new construction home in Raleigh right now that's full of studs and full of wires and pipes, and the performance of that, if you were to put it in a laboratory and test the performance of it, our doors and windows are equal to that insulated wall. So that's how well insulated they are. There's 3 panes of glass, with the airspace in between. The glass is actually laminated. So think about like your car windshield and how, what happens. So even from a safety perspective, like this glass isn't going to break. So it creates a safety component. And then the door and window frames themselves are special because they're thermally broken. And so what that means is what's the material on the outside doesn't go all the way to the inside. So say it's a summer day, it's super hot, the sun's blasting, that outside window frame would feel hot to the touch. But that energy is not going to translate to the inside. The inside will actually feel cool to the touch, vice versa in winter, right? So you're not, the heating and cooling that you're dumping into your house, you're not losing outside. And the same for the, what's happening outside isn't getting translated to inside. And so breaking down thermal bridges is a huge component of the envelope. So we have a lot of steel on the outside of this house, but literally none of it translates to the inside. So if that steel gets hot or cold, it's not bringing that energy into the house. So we don't have to heat and cool that energy.
So there's a lot of thought that goes into how the indoors works with the outdoors, and you have to in this climate, certainly. How does that impact the design, the thought that goes into the mechanicals, the HVAC system in a house like this?
Well, so once we've established this very efficient envelope, and we want to invest in that envelope because once a home is built, that the envelope component of it, the way it's framed, the way it's insulated, the way the wires are run, the pipes are run, you don't usually revisit those things, right?
Right.
I mean, we've been remodeling contractors for 20 years. Like rarely do we change insulation in a house.
Yeah.
Right. So you invest in that so that you reap that benefit of those energy savings for decades, potentially. I mean, we were building these houses to last well over 100 years. That's our timeline on these. So you're getting that built-in energy savings and efficiency for decades to come. And so then you start focusing on things like the HVAC. Part of building a really good envelope is also air tightness. So a typical home built today is a little bit leaky, right? So the air is coming in through windows, like cracks in windows, cracks in doors, cracks in finishes. This envelope is airtight, as airtight as we can get it. The way we measure air tightness is by air changes per hour, and we actually have a machine that we can do that, where it's called a blower door test. We hook this thing up to a door, and we circulate. We pressurize the house and see how leaky it is. A typical home in Raleigh is probably having 3 air changes per hour. So that means that all that air that's inside is changing 3 times an hour. So the Passive House standard is 0.6 changes per hour, and 920, the house that we're wrapping up, just clocked in at 0.41 air changes per hour. So we're coming in well below that Passive House standard. So again, that's a ton of energy efficiency.
And were you nervous while waiting for those results to come in, or did you already know that the results were going to be really good based on the envelope that's in the house and everything else that had gone into the design? I would imagine you're still a little
I knew
bit...
they were going to be good. I didn't know how good, right? Getting below that 0.6 is really what we were aiming for. We got below 0.6 in this house. But we also had a buyer over there that was paying attention, and he was like, show me the results, show me the results. So, we were a little bit relieved that we came in at that 0.41. There's a company, a building supply company that specializes in Passive House construction components. They're called 0.475 because that's their number. And they literally named their company.
That's that. Okay. Pretty good way to name a company.
475. So when you create that airtight envelope, you asked about HVAC. So the V in HVAC is ventilation, right? So now we need to make sure that we have good fresh air inside the home. So we're doing that mechanically with an ERV. It's called an energy recovery ventilator. And so what it does is it takes in fresh air from the outside, it filters it. You can be in charge, the buyer or the owner can be in charge of the actual filtration. So they can put a HEPA filter in there, they can put a special allergen filter in there. They can really control the quality of that indoor air. It dehumidifies that air if it's, a day like today in the middle of the summer. So we're bringing in fresh, filtered, dehumidified, clean air and circulating it through the house. That goes in through the central air system. Then the air that's going out is from our bathroom areas, things like that, where there's smelly, moist air. So we're always filtering air, fresh, clean air into the house.
And does that have any additional benefits beyond the energy efficiency aspects of the home? We all recently went through COVID a few years ago and are appreciating the idea of freeing clean, fresh air.
I mean, these homes literally represent the highest standard you could have for clean air inside a home. So not only are we filtering the air, and you could use a HEPA filter if you want, which would filter out something like a virus. We're also, all our materials inside are low to no VOC, right? Because the other thing that happens when you're living in a tight envelope is all the stuff inside the house can be off-gassing, putting things in there that you don't want to breathe, right? So it's super important that all our paints, all our plywoods, like the cabinetry materials, the paints on the cabinets, on the walls, finishes on the floors, finishes inside the walls, all these materials are thoughtfully chosen to be low or no VOC. So someone with any kind of indoor air quality issues, allergies, could live in one of these homes really well.
Okay.
So that's the V and the HVAC. The H and the AC are the heating and cooling. So we're using, because our envelope's so efficient, we can use a much smaller HVAC unit now, right? So that's another way we're using less energy.
You're taking pressure off the mechanical system.
A home the size of a typical home in Raleigh, the size of these homes would probably use 3 to 4 tons of heating and cooling. We're using 1.25 tons.
Wow, so less than half of what?
Less than half. This home that we're in actually uses 0.9, but we made some changes and bumped it up a little bit for the new homes, partially because they're slightly larger, also because we just want to have less margin of error. But we're using some high efficiency train equipment that's variable speed, so it can ramp up as needed. Use that extra energy when needed, but ramp down and not use any extra energy when you don't need it. So that's a heat pump. And Trane's a good brand, and it's importantly, it's a good brand that lots of folks know how to work on. So and maintain, right? So one of the lessons we learned in this home is we used probably a slightly more efficient, more interesting piece of HVAC equipment that also happened to do our hot water in this home, but we quickly learned that there's not many technicians available, so.
Which is important because people not only think about the purchase price of a home, right, and that upfront initial cost, but they think about ongoing cost and how the home is going to perform, age, and be maintained over time. And it sounds like it's the design thought about that and took that into account.
Very much so. Very much so. Yeah, so I think that covers the main points of the HVAC.
And I think when people think passive, when they think homes that are capable of reaching that kind of net zero status, they start with what's on the roof and looking at the solar. But how I think we're all drawn to that because it's a visual, easy to understand concept of design and how that plays into it. But how big does the solar aspect of this play into the passive design?
So again, in 2 ways, right? So our envelope is designed to keep us all nice and happy inside, but it's also fending off the outside, right? So on a day like today, when it's probably going to get 90 degrees, that envelope is keeping that 90 degree plus temperature and humidity out. So it does, in this case, it's doing it in 2 ways. One is through what we call passive solar, which is really just a simple idea of let's keep the sun out when it's hot out, so we're not heating up our house any more than we need to from the sun, but let's let it in the winter when the free heat from the sun is a bonus. That's right. So it's really just some shading techniques. We know that where we are in our parallel of North Carolina, so we know that the sun is higher in the summer. So we can get the right size shading to shade that summer sun out. And then we know that it's lower in the winter, so we can allow that winter sun that come in and get that free heat from the sun. And then we're also thinking about it directionally. So we've got, this is south facing. So it's also the free daylight too, right? So we want to get a lot of glass on the south side, and then invite that free daylight in, and but do the right kind of shading to keep the extra sun energy out, but then also drink in that winter sun when it's wintertime. And then on the east side, in this case, we have very little glass. We do have some in the primary suite, where you're waking up in the morning. And then we have a little bit on the west side, which is the hardest sun to deal with in the winter. And we have some, an option for some movable exterior shading. Part of the form of the house is a big sort of west-facing screen that gives privacy and shades that west sun.
So that wasn't just for looks; that was also part of the design.
If we think about modernism and form follows function, that's literally the form following that function, being a passive solar home and being an energy efficient home. And then on the north side, we have we never get direct daylight, and where we are here in North Carolina, so we get indirect light. It's really nice lighting. So we put high windows on the north side, knowing that these homes are stacked. So it creates privacy from one home to the other. So that was also sort of taken into consideration from a sort of development perspective.
Is there a way to say, I like the way you just put it, in modernist homes that the form follows the function? An idea of how you're able to pull off, how your team was able to pull off interiors and exteriors that are elegant, that feel like luxury, that are very high end, while keeping an eye on the design that must be met to make the homes perform the way that you wanted them to.
Well, both are must-haves, right? Nobody, Corbusier said buildings are machines for living, and so there is a machine aspect to these homes. They're very technical, and they're very high performance. I think we're going to start calling them ultra high performance homes. But the living is a huge part of that sentence as well, right? So we need to be happy living in these homes. So things like fresh air, the resultant of the things of a good envelope is also, they're very quiet homes. Yeah. Like, the outdoor noise isn't creeping in. They're, like we were talking about the air quality, because we're managing the air that comes in now, we can control the quality of the air. And then the daylighting. Studies have shown, that folks that live in natural daylight, students who learn in classes with natural daylight, have less cavities, grow taller, and get better grades. Direct correlation. That's right. Yeah. That's right. So we're creating those effects inside, and then we have nice spaces. Like we're also architectural designers, so we know what good space is. We know what good amenities are. We know when there's too much. Like, we've tried to right size these homes, so they're not just about having massive amounts of square footage. They're about having the right amount of square footage and laying out in a way that's useful for a typical family, or anyone that might want to occupy the home. We've built in flexibility in the plans, so we have a basement space that can be connected to the main home, or it can be disconnected from the main home. So in this home, the basement is a separate apartment, it has its own entrance. So that could be a mother-in-law suite for me. That could be an Airbnb rental income component for me, or a long-term rental. The buyers of 920 have elected to make it part of their home. They've added a couple extra bedrooms and a little snack bar area, and it'll be like a rec room with a couple of guest rooms for them. There's a full bath, fully accessible bathroom in the basement. So we've tried to build in long-term flexibility with that plan.
So someone can come in and kind of make this their own, or make it work for their family, make it work for themselves, while still keeping in mind the design of the home and not upsetting anything that would deter from the passive aspect of the design.
That's right. I think the passive components are the things that make the home run energy efficiently are pretty well baked into the structure and the way things are laid out. So I don't think anyone could really monkey with that too badly. And I don't think there's anything that anyone would, I'd like to think there's nothing that anyone would want to change about these homes that would interfere with that, right? Because what would that be? Like closing off windows or
natural gas appliances?
Yeah.
That's the question I had. If, like you said, a lot of your work is dealing with people who naturally want to be good stewards of the planet. They want to live in a healthier place. They want to build a healthier place for their family. Are there some non-starters that I've got to have this in my house that won't help you check the boxes you need to get to that low energy score?
I think it's a great question. So we did, we intentionally were all electric because we are solar powered here. So we touched on the passive solar aspects, but we're also using what's referred to as active solar, and that we have a PV system. Again, because the house is so efficient, we're able to do this whole house with 9 kW of photovoltaic energy. And then we also use a Tesla Powerwall battery. So any energy that we don't use during the day charges the battery, and then at night that battery is putting that energy back into the home. So that's part of how we're running off of the sun 24 hours a day. And also that Powerwall is a smart battery. It's tied to the internet. So occasionally I'll get an alert on my phone. It'll say a storm's coming. We're going to save more energy in your battery. So it's also your backup generator.
Us was anticipating what's about to happen and adjusting its performance accordingly.
That's right. And so it's literally a backup generator. Our office operates this way in a net zero way with battery backup, and the power will go off and we won't even know it. Everything stays on. It's not like the lights go off and the emergency lights come on or anything like that.
You don't hear this loud generator kick on, obviously, like most people have.
So you don't need a diesel or fossil fuel powered generator. All our appliances are electric. The technology's there now, like induction cooking. Anyone that's worked with it will tell you that it's just as good as gas. We're using super energy efficient, right, super effective. We're using heat pump dryers. Again, I've lived with this setup for a year and a half now. It's indistinguishable from a conventional dryer.
And how much of that, again, I'm going to back up a little bit to the design phase of your personal home here and the other homes at Tower. You mentioned having to go to Germany to get the windows and having to really think about every shred, every detail in the house. Compared to an average home in Raleigh, how long did it take to design these? Bringing up some bad memories.
We're not done yet. I think it took a career in some ways because they are based on a lot of learning from years and years of working with clients, working with building materials, working with systems, paying attention to what's changing in the industry. We've used a lot of emerging sort of industry things, components in these buildings, systems, technologies, thinking, this is very cutting edge thinking. I mean, my joke is we were building this first house, which we really built it intentionally as a prototype, knowing that we were going to, some people say cutting edge. I say we're bleeding edge because, we were bleeding as we were doing this. But we learned so much that we then translated into these other 3 homes, and I think really got it right. Not to say there's anything wrong with this home, but these homes are designed to be handed off to others, so they need to be easy to operate, very reliable. So no bleeding edge.
Yeah, that this was the guinea pig, and but I like the way you said earlier that it's not only bleeding edge, cutting edge technology that you use, but you relied on some old tried and true building practices that over your career, I'm assuming you've learned are the way to go.
That's right. All the good design principles that we know, even sort of back to that sort of college design, sort of modernist legacy, that plays into all this. What are a lot of the details that people like to, that we've learned, which way doors should swing, what people want in their cabinets, what do people want in their bathrooms, how big does a closet really need to be? A lot of times people think they want things, and then, how many garden tubs have we torn out, as remodeling contractors? And like every single one that we've ever encountered. So there's just a lot of lessons that we've learned like that we try to bake into these homes.
I like the way that you put it earlier, Will, that in 100 years, someone could drive by and still see people living enjoying these homes. And that's amazing, the way that homes are just kind of mass produced in today's environment, and you see them being built and you can't imagine them hanging around for that long.
Disposable homes.
Disposable homes, exactly. What are some of the components in this one, in addition to the energy efficiency? Everybody's got to have home automation now. I want that light to come on either via my phone or a different way. Talk about some of the just ease of maneuvering through the house and living in the house kind of components that went into the thought there.
Sure. So back to our conversation about using German products. There's some folks in Germany called Luxona that have developed probably the best home automation system that I've seen. That's also centered on energy efficiency, right? So we've just got our first one up and running in 920, and our installer is just like, his jaw has dropped. He's like, we're running all the lights in this entire home, inside and outside, with 500 watts. That's equivalent of 5 100-watt light bulbs.
That's just, yeah.
So between using the LED lighting and the energy efficient way that tool translates that energy from AC to DC, it's 500 watts. So remarkable.
It's crazy, yeah.
And it's also a tool that can operate your security system, your lighting system, your sound system, a camera system. About anything that you can imagine can be automated through this system. It has occupancy sensors, so if you want it to pick you up when recognize you when you walk in the door, which it can also unlock for you, unlock behind you. So it can see you come in, unlock the door, let you in, start playing the music that you want to hear, set the lights how you want to hear them. Just any number of sort of automated
like a concierge
peripherals.
in addition to a home automation.
That's
kind of
right.
system.
So it's pretty amazing, and it can also be very simplified too. It still can have light switches, and you can also use those switches to turn on music and operate anything. So it'll do blinds. So we're super excited about that. We've wired these homes to the hilt, pre-wired them so that people can have a lot of optionality around that. So you can choose very little. Because the wire's there, you can choose it as you live in the house over the years. So, 2 years later, you're like, I really would like to have whatever, some shades on those windows. So we've created a lot of optionality around that. The door lock on the main door is integrated, so you can't even tell that it's there. And then we can add electronic locks to the other doors that are all on the same system. So we're super excited about that.
Yeah, really elegant way to add a kind of a creature comfort or something that more and more people must have today. That's also that also works well with the design of the home and keeps that in mind, and is gonna work with a homeowner as their day-to-day may change a little bit in the future.
That's right. And it's all designed to make their life easier and better, right?
Just like these houses, right?
That's right. And healthier.
And healthier. All right, we're at Tower in Raleigh. Please check out our website, which is towerraleigh.com. Will, as you can tell, is a mountain of information about how these homes were designed and then built and how they will perform for years to come. He's happy to bend your ear about it as well. So check out towerraleigh.com and please come see these homes that are nearing completion, and they are truly amazing.